evaluate the integral from 2 to 5, definite integral of x e to the x dx using integration by parts. So hopefully you don't need to be told that you need to use integration by parts. You can see a nice product there. It's a very standard integration by parts, very friendly actually. So we have the integral from 5 to 2 of x e to the x dx. So integration by parts, so we have the integral of u v dashed equals u v minus the integral of u dashed v. So we need to pick a u and a v dashed. Remember, we're going to have to differentiate the u and we're going to have to integrate the v dashed. So e to the x, whether I integrate it or differentiate it, it's going to still be e to the x, but the x, if I differentiate it, that's going to be 1, which is really handy. If I integrate it, it's going to be x squared over 2, so much more useful as a 1. So that is going to be my u. E to the x is going to be v dashed, so that means u equals x. U dashed must equal 1. V we don't know, well we do know. V dashed is e to the x, so that means v is also e to the x. Just separate that. So now we have, and remember this is an antiderivative thing, so we've got to evaluate it for all the points. U v dashed, so that would be x e to the x, x e to the x minus the integral of u dashed v, so that is 1 times e to the x, so that will just be e to the x dx. And we're going to evaluate all of that between 5 and 2. So don't worry that your limits aren't here, they'll be dealt with anyway. So this ends up being x e to the x, well this is just e to the x anyway, so minus e to the x. Evaluated at 5 and at 2, and actually might as well make it as easy as possible by taking out the factor of e to the x, so equals e to the x, x minus 1, evaluated at 5 and at 2, and we subtract 1 to the other, so 1 from the other, so that's what we're going to do. So equals, so we do the expression for 5, e to the 5 times 5 minus 1, which would be 4, minus, well it's e squared times 2 minus 1. So that must be times 1. So we end up with 4 e to the 5 minus e squared.